6-meter ladder is placed in a smooth, frictionless wall. If the ladder's weight is 100 newtons and the coefficient of friction on the floor is 0.7, what is the maximum distance along the floor that the ladder could be placed without it slipping? Here are some important steps to follow. First, draw a free body diagram. Second, choose a pivot point. Third, determine the x and y components of the forces acting on the beam. Fourth, let T net equals 0 and F net equals 0. Fifth, solve! Now let's get started. Step 1. Diagram. Here's our frictionless wall, our 6-meter ladder, our center of gravity, force of friction, normal force by the wall, and the normal force exerted by the floor. Step 2. Pivot point. From your diagram, choose any pivot point from your ladder or beam. Step 3. X and Y forces. In the x direction, we have force of friction and the normal force exerted by the wall. In the y direction, we have center of gravity and the normal force exerted by the ground. We let Fx equal 0 so that the force of friction would equal the normal force exerted by the wall. By that, we get the coefficient of friction times normal force, and by letting Fy equal 0, center of gravity would equal the normal force, which would be 100 newtons, which we can then plug into our previous equation, giving us 0.7 times 100 equals 70 newtons. Step 4. Equation. Remember that the angle is relative to the pivot point. Our net torque is 0, making our clockwise torque equals our counterclockwise torque. The net force exerted by the wall is our counterclockwise torque, while our clockwise torque is our center of gravity, giving us the equation of WD cosine theta equals FD sine theta.
Step 5. Solve. From the previous equation that we got, we can just plug in our numbers, giving us sine theta and cosine theta as our unknown variables. We can just isolate these variables, giving us sine theta over cosine theta, also known as tan theta. And by making sure that our calculator is in degrees, we can just use tan inverse to figure out the angle of our torque, which is 35.5. Since we know our angle and the length of our ladder, we can figure out the maximum distance that the ladder can be placed without it slipping by using cosine, rearranging for x giving us 4.9 meters.